In this video, I'm going to solve 4 questions from the chapter Application of Integrals, and that is from the exercise 8.1 textbook, CBSC, sorry, NCERT textbook, and that's for the new syllabus or rationalized syllabus. Now, let's begin with the first question. So, in the first question, it says that find the area of the region bounded by the ellipse, and the ellipse is this. Now, the first thing that you will do here is to write the equation in the standard form. So it's going to be what? X square over 4 square plus y square over 3 square is equal to 1. From here, we can see that the origin is 0, 0, and A is 4, B is 3. Further, you can also figure out that let me draw the figure that will give you a clear idea what I'm saying about. So let's say make an Cartesian plane and then an ellipse. You can see from the question that here the major axis is along the x-axis. So I'm going to name these points as 4, 0. This is 0, 3. This is going to be minus 4, 0. And this will be 0, minus 3. Now check, we have to find the area of this whole thing, the ellipse. But then we'll be first finding the area of only this region and we'll be multiplying by 4. Now reason here is that as you can see that in this given curve, which is an ellipse and its center is origin, that is 0, 0. And further you can also see that this is symmetrical about the x as well as y axis. You can check from here as this figure is symmetrical. The same thing is over here. And it is symmetrical about the y-axis as well. As you can see that on flipping this part along the y-axis, they get superimposed. So therefore, we'll just be finding the area of this region and multiply by 4. This is the shaded region. You may name it as say O, A, B, O. So we can say that the required area in this case, let me write down. So we'll say that the required area will be what? That's 4 multiplied by the area bounded by this figure OABO. Now, next thing that you'll do is to draw a vertical strip, maybe or horizontal will also work. Over here, I'm drawing a vertical strip and I'll shed this, right? Now, what next you'll be doing that we'll be saying that it is 4 multiplied by, this is fx and fx is y here. So I'll be writing y dx, right? And the limit, as you can see from here, is 0 to 4. So the limit here is 0 to 4. Now next, once you have written this, we are going to isolate y from here, right? I'm going to isolate this y from here. So what I'm going to do is to transpose. So it comes as what on transposing? This is 1 minus x square over 16, and that divided by 9. Sorry, it's multiplied by 9. Right, this 9, right? So we can figure out that if I find it's under root 9, first I'll take LCM, is going to be what? 16 minus, the LCM in the numerator is going to be 16 minus x squared, that divided by 16 and multiplied by 9. Now for further simplification, this is y square as of now y will be equal to under root of 9 is 3, under root of 16 is 4, and that multiplied by 16, which I can write 4 square minus x square. So I'm going to replace this y here, right? I'm going to replace this y. So if I do so, what I'll get here, I'll get whatever the area is, what? 4 times the integration of y dx. And as I said, y can be replaced with this. So let's see if I write 3 by 4 outside, and y, which I said is replaced by, this is 4 square minus x square. Now check here. This is 4 square minus x square. There's dx as well. I can integrate using this formula. So its integration is what? let's say I solve it here. Let's minimize these things. So its integration is what? This is, if I reduce, this is coming as what? 3. And integration of this using this formula is x over 2, that is x over 2 under root a square minus x square, that is 16 minus x square plus a square by 2. What is a here? A is 4, right? So 4 square is 16 over 2 sine inverse x over a, and a is 4, right? And the limit on placing, the limit is from 0 to 4. Limit is here 0 to 4. Now next is what we'll be placing the limit. So the required area, what we are getting here is going to be what? This is 3. Now if I place the upper limit here, you can see that on placing 4 over here, right? I will show it again. If I replace this with 4, this is what? 4 square minus 4, 16, right? So 4 square is 16, 16 minus 16 is 0. So this will vanish, right? This will turn as 0. Let me show it also. This will come as 0 plus, on replacing this with what? 4 is going to be sine inverse 1, and sine inverse 1 is what? Pi by 2, and this is 8. So it's going to be 8 multiplied by pi by 2. That's about the upper limit. Now coming to the lower limit here, what we get as the lower limit, now replacing x with 0. So 0 multiplied by any number is 0. So this is coming as 0 again. So we'll say this is 0, and then plus, what you can figure out, this is sine inverse 0, right? Sine inverse 0 is what? 0. Sine inverse 0 is 0. So this is 0 again. So now the final part that we'll get here is 3 times, this is what? 4 pi multiplied by 4 pi. So it should give you how much? 4 into 2, 3, that is 12 pi, and you must write on square unit, right? So this is how the first part, first question that I've selected out of 4 is done. Now let's move to the next. Now in the second question, it's very similar to the first question. As you can see, this is an ellipse. Now the difference, as I can observe from here, that here the major axis is along y-axis. So if I write this equation, this is x square by 2 square plus y square by 3 square is equal to 1. So this says that the major axis is along the y-axis. Now the first thing that we do as usual will be making the Cartesian plane, and this time I'm going to make an ellipse along the major axis, keeping in mind that major axis is along the y-axis. All right. Now, similar to the previous question, here also we'll be first finding the area of this and we'll be multiplying by 4. But before that, we need to make a strip here. I'm going to make a vertical strip here. Right. So next, I'm shedding the area that I have to determine. That is this area here we'll be finding out and multiplying by 4. So once you have done with this, let's keep it aside. And we'll write down the statement, that is whatever the area we have to find out is will be 4 times the area of the shaded region. You mean in turn, what you can do, the other thing that you can do over here is to write down this figure as O, A, B, and name it. Now, irrespective whatever you are doing here, what you are going to do next is to for integration. Here we can figure out that the shaded region is vertical axis. That's length is along y. So y dx is what you'll be writing. And I didn't write down one important thing, that here you can see from here that is x is 2. So it's going to be 2, 0, and this is, that's 0, 3. And so is this. This is minus 2, 0, and this is going to be 0, minus 3. So the limit you can figure out from here is what? 0 to 2 for this part, right? For this part. Now I have to isolate y. We have to obtain y in terms of x. So let's make some space for here. So from here, I'm going to obtain y. So what I'm going to get here is what? Y square will come as 1 minus x square by 4. And this is what? I can transpose 3 also, right? This is 3 square over here becomes 9. So y will come as what? If I find the under root of this comes out to be, okay, let me do it in a step. So the LCM is what? 4 minus x square over 4 that multiplied by 9. This is y square. So y will come off under root of this, which is 3 over 2, and then whole under root. 4 is what? 2 square minus x square. Now check here, we can apply this formula for finding the integration. So this is 4 integrals 0 to 2. And as I said, I'm going to replace this y here, right? So this replacing this y from here, what we are getting is 3 over 2 outside, and then this is 2 square minus x square. All right, next is to find its limit. So this can be reduced here by 2 times. So we get this area as 3 into 2, that is 6. And applying this formula of integration with x over 2, which is x over 2 only, under root a square, which is 4 minus x square. This is 4 minus x square plus a square over 2, that is a square is what? 4. 4 over 2 sine inverse x by a is 2, right? And then placing the limit, and the limit is what? It's 0 to 2. Now check here, this can be, this is what? 6 is outside, right? So it's a need to keep in mind that 6 should not be enclosed inside the bracket. All right. Now applying the limit here, let's say if I place the upper limit here, upper limit is what? 2 here. Replacing this with 2 is what? 4 minus 4 is 0, and 0 multiplied by any number is 0. So it's going to be 0 plus, now this is 2 here, and if I replace this x with 2, this becomes what? Sine inverse, right? This is sine inverse 1, which is what? Pi by 2. So it's 2 multiplied by pi by 2. That's for the upper limit minus the lower limit. Check here, if I place x as 0, 0 multiplied by any number is 0. So this is going to be 0 plus this is, if I replace this x with 0, so 0 divided by 2 is 0, and sine inverse 0 is what? 0, and 0 multiplied by 2 is 0. So this is 0 only. Now for the next, this I see can get cancelled here, and in turn we will get what? 6 into pi. So 6 pi square unit should be the answer for this part. Now let's move to the next question. The next question, which is an MCQ, right? So we have to find the area of the first quadrant bounded by the circle, equation of the circle given, and x is equal to 0 and x is equal to 2. So what we are going to do first thing is to make a diagram. So I made this Cartesian plane first here, and we can see this is an equation of a circle with, if I rewrite this equation, this is what? X square plus y square is equal to 2 square. So clearly here, center is 0, 0, and the radius is 2. So we'll make a circle first. Let's say I make a circle here. And we can figure out from here that the radius, center is 0, 0, and radius is 2. So it's going to be 2, 0. This is 0, 2. This is minus 2, 0. And this is 0, minus 2. Now we just have to find the area of this in the first quadrant. So this is what we are required to find out. Further, the bounded by this and the line which is x is equal to 0. So what is x is equal to 0? X is equal to 0 is y-axis itself, right? So x is equal to 0 is y-axis itself. So let's say this, And we have another, that is x is equal to 2 is what? A line parallel to y-axis and passing through this. So we can figure out that what area we have to find out. One more time, we have to find the area of the region bounded by these lines and the curve. So curve, you can say this is the curve here, and the lines is this, and that of the, what's that? Yeah, first quadrant. The first quadrant is this only. So now I'll set this region only. I'll set this region. We have to get the area of this. Already shed it, right? No need to do it again. Now, next is to find integrals. So what I'm going to do here, one more thing that I forgot is to make a strip here. The strip here, I'm going to make rectangular strip, and making it along the, its length is along the y. So we'll say that the required area here is equal to integration. That is limit here is 0 to 2. First I'll write y dx, right? This is y dx, and the limit along the x-axis is 0 to 2. Now we need to isolate y from here. So I can see that from here I can get what? Y square is coming as 2 square minus x square. And if I remove this square from this side, we'll get under root of this. So again, this question is also based on the same formula. Now check what we have to do is to replace this y here. So once again, I'll be writing this area is equal to integrals 0 to 2. Y I can replace from here, and what comes y as? Y I can replace as this is 2 square minus x square, and this is dx. Now for further, I'm going to apply the formula for finding the integration of this. So let's say if I have to get the area, and the formula is what? This is x over 2. This is x over 2 under root a square. That's a square minus a square is 4. 4 minus x square plus a square, that is again is 4 by 2 sine inverse x by a. And what is x here? X is x, a is 2 here. Now check here, we have a limit here that is 0 to 2. Now I'm going to place the limit in the next step. So first I'll place the upper limit. Now placing the upper limit here, upper limit is what? 2. So I can see that placing 2 here, 2 square is 4, 4 minus 4 is 0. So this is going to be 0. Plus this is how much? 2 here. So this is 2 multiplied by, replacing this x with 2 is sine inverse 1, which is pi by 2. This is the upper limit minus the lower limit, replacing x with 0 here. This becomes 0. So 0 multiplied by any number is 0. So it's 0 plus, what is this? 2 times. This is what? Sine inverse. Placing this as 0, we are getting sine inverse 0. So sine inverse 0 is 0. So this 2 multiplied by 0 is 0. So we'll be writing 0 here. So now this also get cancelled. So now we get the area as pi square unit. Right, and the correct option therefore has to be the first one. Now let's move to the next question. Now in the fourth question, you can see that we have to find the area of the region bounded by this y square is equal to 4x, y-axis, and the line y is equal to 3. So as usual, we'll be first making the plane here, and we have to make an ellipse. But what you can figure out from here, this is y square is equal to 4x. So y being positive, negative, x is positive. So it has to be a rightward parabola. So I'll first make a parabola. Let's say if I, in order to make a parabola, I'll just be converting them into parabola. Let's say I made a parabola. Now next thing that I'll do here is to, And moreover, you can see that here it's a vertex, right? Is 0, 0, right? So let's make it. That's fine. Now this is the parabola here, and then next is what? Y-axis. So y-axis, I should highlight in the y-axis. This is what? The y-axis. This is what the y-axis here. And there is one more. Y is equal to 3 is what? A line parallel to x-axis and passing through 3. Let's make a line closer to this. All right. So let's say this is 0, 3, right? This is 0, 3. So this is 2 and 1. So what we have to do is to find the area of this region, to get the area of this particular region. Now for here, we have to make an horizontal strip. This is important to remember that the strip we are going to make is a horizontal one, like this one. And let's see if I show it properly. Now let's put it aside. So here the required area is, or the area of the shaded region, as you can see that is bounded by this curve, and it should be here the strip rectangle whose length is along the x-axis, so it should be x dy integration. The limit here is what? Limit is along the y-axis, so it's 0 and this is 3, so it should be 0 to 3. Now next is to isolate x from here. So clearly from here what you can see, x is what? 1 over 4 y square. That's what we are going to do in the next step. So this is area is equal to, this is integration 0 to 3. I'm replacing x here, and as I said, x is what? 1 over 4 and then y square dy. Now this area is what? This is 1 over 4. Y square integration is what? Y raised to the power 3 divided by 3. So I'll write it here. And the limit is what? 0 to 3. The limit here is 0 to 3. Now this is what comes out to be 1 over 12. Right. So if I place the upper limit, which is 3, so this is 3 raised to the power 3. The upper limit is 3 here. Right. This is also it again. This is upper limit place replacing y with 3. So it's 3 cube, and lower limit is 0, 0 cube. So what we get area here as, this is 1 over 12 multiplied 3 raised to the power 3 is what? 27. So I can say this can be reduced 3 4 times and 3 9 times. So finally we'll say the area comes out to be 9 over 4 square unit. This much square unit. Well, answer is what? Now this is B is the correct, right? So it's B here in this case.